Alright, it's happened to all of us. We're working on some code, everything's been going great, and we decide to run a test, the program crashes. We go back and look at the code we just changed, and there's no reason that code should have caused the program to crash. Thus ensues a painful process of commenting things out, deleting lines of code, tweaking, cursing at the computer, until we finally figure out that we forgot to initialize a variable somewhere, or something like this. And so it just finally randomly decided to reveal itself to us. This is a painful process. Coding in general can be difficult, and making small mistakes that hide can be just nightmarish. So there are some really intelligent people who created tools for us to make the process of debugging, finding the problems in our code, much easier. So we can actually apply some systemic rigor to finding the issue and fixing it. And that's the topic of this video. So I'm going to tell you about a tool called GDB, which is a debugger that is freely available, and you'll find it on most. I find it available on virtually all Unix systems, whether it's been installed or not. It's available, and we're going to show how to use that to deal with such a problem. Now, to simulate the kinds of mistakes that could happen, I've modified the main.c file for this dog sorting program that I've been fiddling around with in previous videos. So you see where here on line 14 I have commented out the part of that statement that allocates memory for the variable some dogs to point to. So some dogs is being created. There's some value in that pointer, but I don't know what it is. So it's pointing off to La La Land or to 0, I don't know. But it's pointing somewhere in memory. And I could randomly end up with it pointing to memory that I'm allowed to touch. Probably it's pointing to memory I'm not allowed to touch. And so when I try to run this, it's going to crash. And it'll crash by giving me a seg fault. Most commonly when we see a seg fault, it's because we've tried to access memory we're not allowed to touch. Okay, so this is just simulating that. Now, these things can be really nasty because, again, sometimes we may randomly end up touching a piece of memory we are allowed to touch. But we're not doing so intentionally in that case. It's an accident. And so now we're changing data that we didn't know we were changing. And that's even worse because now the program runs for a little while and then crashes because that memory's been corrupted. And now we have no idea what the root of the problem actually is. So we want to see a seg fault if we're trying to access memory we shouldn't. This modification should cause us to see one. So let's go ahead and write this out. I'm going to do a make clean. You can see I've been clean that up. I've been fighting with this a little bit, trying to get ready to talk to you all about it. So now I'll do a make. And now I'm getting a warning that, hey, you're using this variable, but it might be uninitialized. It's a good reason to not ignore warnings. I might not notice that particular warning if I've just been ignoring them, and now I have 50 warnings every time I compile. Whereas if it's the first one that shows up, it catches my attention, and then I go deal with it and keep the warnings short or non-existent. So there's a good reason there for eliminating warnings, but we'll say we're in a bad habit of ignoring them. It's just a warning, who cares, it built. And it did. Indeed, we haven't broken any rules of the language. So let's try and run the program. And forgot to give it an argument. All right, and then we'll just say Buster and Tutu. All right, we get segmentation fault. So in the scenario we're simulating, this is where we go, oh no, where could that be? Instead of just blindly trying to find the problem in the code, let's try to use the debugger. So first we'll make sure we've got it. GDB, which GDB? And sure enough, on Kentucky we have access to GDB at user bin. So I'll launch GDB and I'll pass it the argument sort dogs, the name of the program I'd like to debug. Now, we loaded it up. There's a bunch of mumbo jumbo gibberish here. And then we see this line right here. It says reading symbols from sort dogs, no debugging symbols found, done. That statement, no debugging symbols found, is going to be important to us in just a moment. For now, I just want to draw your attention to it. Notice that it said that. All right, how do we run our program in GDB? Well, we type run. And if I try to do that, it complains. It shows me the usage message we're used to seeing because we didn't provide a command line argument. How am I going to give a command line argument in GDB? I'm not at the command line. The folks who developed GDB knew you'd need to give command line arguments in many situations, and so when we type run, we can then also provide command line arguments just like we normally would. So when you say run, you're saying run my program, and then here are the arguments for it. So I can do the same kind of thing I did before, and we see that we get the segfault. Now, already we see part of the usefulness of the debugger. Notice this hexadecimal number right here. Well, that's an address. That's telling me the address of the instruction where the program crashed, where something bad happened. And it's telling me it's in a function called printdogs. If I want to see more information, I can type backtrace. And now I can see the listing of the functions that are currently active on the stack, meaning the functions that had been called but not returned from when I crashed. So printdogs is on the top. That's the function I'm in, that I was in when I crashed. And I got there from main. Okay, so we see how it stacked things up. If I called another function from printdogs, that would be on top of it in this backtrace. I can also type where, and that does a similar thing, but we'll come back to where in a moment and show you something else that where can do that's very handy. All right, so we're getting some information from the debugger, but I still don't know anything I can really use very much, okay, or use very well. I know this hex address in the executable, but I don't know where in the code that is. Where in my source code is the instruction or instruction, well, it would be an instruction in this case. Where's the statement, we'll say, that became this machine code at this address that has caused the problem? We don't know, and the debugger can't figure that out because of this problem right here. No debugging symbols were found. So it turns out that we can tell our debugger, we can tell our compiler to insert debugging symbols into our program when it compiles it. What on earth does that mean? Well, it means it's actually going to add extra code that it can use to track what's happening, that the debugger can use to track what's happening while the program's executing. And among that, among the abilities that it gives the debugger is the ability to map an instruction back to a line of code in our source files where the problem, where that particular line of machine code originated from. Okay, so yeah, here's the hex address of the machine code in question, and here is the line of code that spawned that machine code when the compiler ran. So it's probably easier to demonstrate this, so let's just go ahead and show you. So I'm going to quit GDB right now. It's warning me, hey, you had a process running. It's this one that segfaulted. I don't care. Okay, go ahead and quit. Yeah, I don't care about that crashed process. So let's go back to Vim, and I'm going to change tabs to the make file, and we're going to change the flags. We're going to add the flag -G, and that tells GCC that it should add debugging symbols. So that slight change is all we need to do. Now I should point out while I'm here, maybe I want to make note that I've edited this, so I can say, hey, changed on such and such date by so and so, something like this, right? I can leave comments in the make file, and that's how you might go about doing that. All right, now if I just type make, you'll notice that it doesn't build anything. It says, hey, everything's up to date, and that's because nothing that I changed just now is showing up in any of my rules as something that has been updated. So I need to force it to build everything, so I'm going to say make clean, and then I'll just run make again. And that's one way of causing these rules to be executed again. So we've got our warning, and we have our executable again. We know that it's prone to crash, so we'll just go right back into GDB, see if we can make it crash again. This time notice that when we reach this point here where it tries to read the symbols from sort dogs, it just says done. So it actually found them now. So I'm going to run the program with one for the command line argument, and we'll give it this. Now look what we have. So it did crash again, and we got the address, okay, of the instruction, but also it says, hey, this happened in print dogs. This is what the arguments were to print dogs. So num dogs was 1, that makes sense. Now dogs, remember, that's the pointer to the array of dogs that we should be working with. And notice it's set to 0. So in this case, we ended up randomly with a null pointer. That's bad. But it also then goes on to tell us at dog.c12. That's the line number. So this is actually giving me a specific line number where I'm going to find the problem. It then prints out, or at least where we will probably find the problem. Now, it could be something else actually happened earlier, and this is where the problem manifested itself, but this is a really good hint, a great place to start. So here we see line 12, and it's actually showing us, hey, it's a printf statement, and I see over here I'm trying to access dogs, and it's a null pointer, and so that's what's causing the seg fault. So here I could go fix my code right now. I know exactly where to go to fix the problem. That fast. Okay. Now, it could be that it's not this easy to diagnose. It's often not. We see where it crashed, but we're not sure exactly why. So I'm going to show you some other tools we can use, some other commands we can use in GDB to be able to dig a little bit deeper. So again, if I type backtrace, then I can see the information I saw before, but with greater detail. It's in main, and here's what main looked like. And in main, on line 17, this is the line where we left main and moved to print dogs, and it was at print dogs line 12 where we crashed. So again, we can work backwards and figure out where things happen. If I go look at line 17, I'll see that this is where print dogs is called. All right, that's all fine and good. Can I look a little bit closer? And can I watch how things are happening during execution? And the answer to that is yes. So first, let's tackle the problem of saying, okay, I know that the program is crashing right here on this line. I'm not totally sure why. So I'd like to stop the program at that point and then be able to slowly watch things as they transpire. So one of the things I can do is I can set a breakpoint. So I'll say break, or we can simply say B, either one. And then we'll give this information. I want to break at dog.c line 12. All right, so now it's set a breakpoint. And now if I hit run, type run 1 again, it says, hey, you've already started this thing to debug it. It's kind of hanging up and waiting for you to look at it right now. Are you wanting to start it again from the beginning? So I'm going to say, yeah, that's exactly what I want. And now if I say buster22, now check this out. Instead of crashing, we've stopped executing, and it's telling us, hey, you're at breakpoint 1. It's showing me the line that that's about to execute. It hasn't, because we put a breakpoint there. And so I can do all kinds of things now. I can say where full, for instance, and I can actually inspect now. Not only am I seeing the call stack here, so I can see print dogs and I can see main.c, but I can also see the local variables. Okay, so this is one of the ways that we can see local variables in the functions that are on the call stack. Okay, so again, those are functions we've called but have not yet returned from. So I can look at these and I can analyze them. You can imagine that can be really useful. I can note that, oh, actually this variable is not what I expected it to be. For instance, some dogs is 0. I expect that to have a useful address, and I know that 0 or null is not a useful address. That's going to crash every time if I try to dereference it. Okay, so this is how we can inspect those things. Now let's say I'd like to allow the program to move forward, but I only want it to move forward by one instruction. Okay, so there are a couple of ways that we can do that, and a couple of ways we can interpret that statement one instruction. I want to point you to a resource you can find just by Googling GDB cheat sheet. And there's this PDF, GDB cheat sheet, and this is great. So here we have GDB commands. It shows us how we can run GDB. It shows us how we can put in breakpoints, okay? Things we can do with down here, yeah, things we can do with where, in terms of what we want to, we're looking at watch points here. Tons of things we can look at. Want to come down to, where is it? Ah, here it is, stepping. Okay, so what is stepping? Stepping is a command that we can use to, stepping deals with stepping through the code step by step instead of running it all at once. So for instance, we can give this step command, which says go to the next instruction, source line, if necessary diving into a function. Next says go to the next instruction, but don't dive into functions. That doesn't mean they're not going to execute. It just means go ahead and let it execute, and then stop at the next instruction after we get back from that function. Finish, continue until the current function returns, or continue, just go ahead and run. So if I was to hit continue, it's going to crash because the next instruction is where it's going to crash, but I'm going to be more fine-grained, and I'm just going to say next, and boom, everything explodes. Get a seg fault. Okay, so these are some of the tools and some of the commands that you can use in GDB to help to debug your program and figure out why it's crashing or why it's behaving erroneously. Again, I point you to this cheat sheet. It gives you just a raft of commands that you can use. I'd honestly have to sit here and think about some of these to be able to remember exactly what they do. And that's why we have a cheat sheet, right? I remember there's a way that I can step. And so, hey, I can look that up and use it again. So this is something you might want to print off, put somewhere useful that you can quickly get to it, or keep a shortcut to it, whatever you want to do. But I recommend having this on hand, and at least one time read through these things and give yourself an idea of what they can do and what's available to you. All right, so we use GDB to find the problem in our code, and ostensibly we would now go and make the changes and fix it, and then continue to test and go forth with our development. So that's where I'm going to leave it with GDB, and hopefully this will be useful to you as you continue to learn more about C and computer systems.